Testing. Oh. Seems to be working. Yeah, sorry, I had to just start again because annoying notifications keep coming up on the screen. So where was I? Yeah, so the aim now is just to finish this document as fast as possible. I've got about 40 minutes. I tried to find out last night on the E13 Discord, but I'm not sure if anyone knows why the reset pin for the QSBI and the chipset pin for the flash has an extra GPIO that can basically reset the flash memory. It's just here for USB boot, and I wonder if it's in one of their bootloaders. I don't know what its function is. Maybe it's for CircuitPython or something, but we're not going to use it, I think. And then I had another realization that the chip select pit for the PS RAM is on a different GPIO, and if you look, it's over here, GPIO 47. But when I was reading this little bit of text that came with the example layout, it says optional secondary RAM PS RAM using the second chip select pin zip number 1 on GPIO, and it says the GPIO will be required as GPIO's default to pull up and pull down at power up. So that means we need to make sure that this is on, I think. So this exists. So this GPIO is on for the PS RAM, but the primary flash is not. But I just wanted to quickly look in the datasheet to see what this extra chip select pin is, if it's like a hardware peripheral or it's just general. So it's in the XIP peripheral, which is how it communicates with a flash chip. It's the processor, RAM, there you go, external flash. I'll put it in browser. I won't read through it all. Cache SRAM. No. Interface. Up to 2 external QSPI devices with separate chip selects. Memory mapped. The registers. Where does it tell you about the pins? Maybe it's at the beginning. Pin locations. So it's GPIO 0. Overcurrent detection. Is the XIP here? What's the XIP interface? It's on pins 75. Oh, here it is. GPIO functions, bank 1. GPIO functions are also available on 6 dedicated QSPI pins. Oh right, so that's funny, they can be used as GPIO as well. That's not what we're looking for. We're looking for GPIO 0, but SPI. There's nothing about. Oh yes, it is. QMI, I think. CS1. Yeah, so I think I'll not do the Adafruit way. I'll do. Move that. No, move chip select. The PSRAM from here. Oh wait, you can't see this, sorry. Moving the chip select up to here to GPIO 0. It's also negative going, so it's enabled when it's negative, when it's low. So I think that's actually a hardware peripheral. Like it's mapped. Maybe it doesn't really matter. I'll turn this back to a general ADC. Okay. And then we were doing the crystal. We've done the physical thing, we just need to lay it out. The funny thing is, in the Rp2350 hardware design thing, it would show you the layout, but for best performance, crystallized pattern. It just says reference to the design file, so I'll do that. I'll open a second KiCad interface. Open the minimal design. As a reference. We want to look at the crystal here. They have all what the best. See, that's Y1, right? So where's Y1? Oh, weird. There's Y1. We got Y1, C3 and C4. Oh. In ours it's called C65 and C66. And they've just got it so I'll just copy that Interesting, I seem to be missing a capacitor too. Oh no, wait, got the 1V 1 capacitor, got 3V 3 capacitor, yeah, I'm missing a 3.3V capacitor. Got 3 up this side, actually 4 here. I'll work that out later. Copy this. Oops. Oh yeah, that'd be nice, I can just use that. It's actually a little bit away from the... Oh, where's it gone? It'll need a priority. Priority 0. Don't know if that's higher. Oh no, that's higher. Oh wait, look, did I lock this? Just want to temporarily move this out of the way, just so I can use this as a little cheat sheet. That's right. Need to move these back in. So it's a bit like this. The reference designators left and right. Oh, that's the resistor, isn't it? It's not capacitor. We need this damping resistor basically. Goes that way. And these. Oh no, not that. Don't see why these can't be like that. I think they're trying to keep the resistors and capacitors far from the footprint so they can replace, you know, hand solder it a bit better, easier. Ah, these are the wrong way around. Are they? No, no, I moved that one back and forth. Go. Probably good to keep a bit that. Don't know, it's just a hunch. No, it's too thick. Oh, I'm using not 2.2. 0.1's a bit thin. What thickness wires are they using? 0.15. Just think about doing that. Not 0.15. And then maybe put some wires in as well. I either put wires close to the ground. There's a nice short ground. Yeah. Now it's just the USB. I'll ignore the I/O headers bit because we're doing something completely different with this chip. I will do the debug connector as well. Got 20 minutes. So the I/O headers. The Rp2350 provides 2 pins to be used for full speed and low speed USB bus. That's USB 2, isn't it? Full speed. Either as a host or device, depending on the software used. Oh, that's interesting. Didn't realise the hardware peripheral could be used as a host. I know you can imitate a host with PIO pins, but as we've already discussed, Rp2350 can also boot a USB mass storage device, so wiring up these pins to the USB connector makes sense. The USB DP DM pins on the Rp2350 do not require any pull-ups or pull-downs required to indicate full speed or low speed, whether it's host or device, as these are built-in IOs. Well, that's good. However, these IOs do require a 27 ohm termination resistors placed close to the chip in order to meet the USB impedance specification. I've got them in there just because I copied it over. Even though the 2350 is limited to full speed data rate 12 megabits a second, we should try and make sure that its characteristic impedance of the transmission lines are close to the USB spec of 90 ohms. On a 1mm thick board such as this, if we use 0.8mm wide tracks with a gap of 1.5 between them, then we should get a differential characteristic of 90 ohms. I'm using a standard 1.6, but with it's interesting to know. What's the layer thickness? Of a 4-layer board? Dielectric thickness. I can't see anything about. I'll have to come back to this later. Even though you've got that on 1 minute. A solid and uninterrupted area of ground copper stretching the entire length of the track on this design is almost entirely of the bottom copper layer and is devoted to ground, and particular care is taken to ensure that the USB tracks pass over nothing but ground. Yes, you can't have traces coming underneath. Now in our design, oh god, we're trying to get here. And where's the USB connections? 67 and 66. Oops. 67 and 66 is... oh, lovely. Oh yeah, it's right here. This means I think I want to rotate the entire design so that if I do that, luckily I'm using a 4-layer board. I was going to use the inner layers as copper, as ground, and other power plates. So what if I put the USB connection? I'll have to work out the impedance later, but what if I put... I think I can do root differential pair. I'm able to find a pair of net because you have to lay them with NP. So what you have to do in KiCad, if you want to use a differential pair, you have to call them for positive P. USB P. No, let's call it D because it's called. Let's call it DP. Like it's. I don't know why they didn't stick to that. PN. And it's going to. In our case, it's going to a header. USB. I'll call it DMDP, but micro. No, N. Why is it M? N. Can I use that naming? I don't know if I can. I might have to call it DN to break the naming convention. Why is it M? DP. Oh, they call it M. I'm sure this is not necessary, but I quite like using it. Called N. End with either NP or plus or minus. That's what we have. Oh. Oh, but that's what we had. Oh, there's resistors first, isn't there? I think the best thing to do would look at the Does the termination resistors place as close to the chip as possible? Sorry. So it's 24 and 43. Strange. So these basically have to be like that. Oh, let's move the silk screen. Got the long way round. Kind of, oops. Oh. Come on. Oh, this is all violating anyway. Come in here. Look at this mess. Millions of little tracks. That doesn't need to be like that. Might use a thinner trace. I'm allowed to use 0.1. Oh, it's because my clearance is massive, look at it. I haven't really set up the board properly. Minimum clearance. Traces. Minimum track for 1 and 2 layers, 0.1. Minimum track width, 0.09 for multi-layer boards. Does that change anything? No, it's still massive. Minimum annular width. Strange. I'm just gonna turn off. I'll have to sort that out later. For now, I just want to connect it. It's meant to just highlight interactive router settings. Allow violations. See that grey around the stroke? That's the distance allowed, and it seems too big. I don't know what it is. Now let's see if this differential routing will work. No. Unable to find pair nets. Make sure the names belonging to different potential pair end with NP or plus minus. Well, they do. plus. Oh, is it N? No, N. Do you think it's meant to be? N. I'll use the underscore. I need to work that out later. What I want it to do is just do this. Probably. Actually, no, I probably want them to go into vias. It's probably a bit of a. It's probably a violation of what you're supposed to do. And then go straight down to the connector. What I'll probably do is change its pin on the connector. I'm just leaving that there for a reminder that I basically want the USB to come straight down here. I've put them at the end, so over here. It might be worth getting them put in at 13 and 12. Oh, they're kind of free as well. And then that will come through a ribbon cable onto the connector board. And then I'll put the USB connector quite close to there. I mean, it's not that essential because it's slow USB. See how this is. Priority. I need to. Wait. Where's that? No, it's up here now. It's flipped around. I'm trying to find this. Oh wait, that's a ground zone. No. Want this zone here. I put it at priority 0. If I made it 2, top one priority 1, does that mean it dominates? Yeah, there you go. So hide these layers. The ground is the ground pole is dominating over the 3.3 volt one. Right. headers, we don't need to worry about that. And then the debug connector. Which, did I bring it in? That's a stem QT connector. Here's the debug connector. Now, I probably want this on this side. Just put it near where it should be. Oh, of course it's near everything else. Because is this module be facing outwards, backwards, I think I'll just... This is a horizontal one, but I think I'll change it to a vertical one. You can do that in the schematic. You press change symbol. Currently it's that one. No, that's the symbol. Footprint is the horizontal version. I think I'll probably change it to the... Although... No, I'll change it to the vertical version. So it's a JST SH connector, and I want O3 vertical. Oh, it's a 15 vertical. That's SHL. O3. Slightly different. Slightly different footprint. That means you will have it just coming straight out the back, and what I'll probably do is just have it up here somewhere. I don't think it has any... No, it doesn't have any parts with it. And then there's a few resistors left, capacitors. Ah. Oh, this is for our switching supply. Oh, this is all our switching supply. I'm going to be doing that next. Ah, these are meant to go next to the PS RAM chips. Oh, I haven't put the PS RAM chips in. Where are they? I don't seem to have. Okay, I've run out of time now. Basically, I've got through the document, but I need to put in the PS RAM chips. The PS RAM chip and the flash chip. That'll be the next video. Anyway, thanks for watching. Bye.